Hello, welcome to Tech Unplugged. Today, we're plunging into the world of something called the Model Context Protocol, or MCP. You shared some really fascinating stuff about this, and our mission today is to really get to the heart of what it is, why it's suddenly the talk of the town in AI circles, and maybe even more importantly, what potential banana peels we might slip on down the road. Think of it as trying to get the lowdown on a tech that some are calling the universal remote for AI, you know? But with a good hard look at whether the batteries might leak, metaphorically speaking, of course.
Yeah, a universal remote for AI. The idea is definitely appealing because right now, getting different AI applications to really work together can feel like you're constantly searching for the right adapter or trying to make sense of totally different instruction manuals. MCP really aims to simplify all of that. The core idea here is MCP wants to be the universal translator for AI, getting rid of all those unique, bespoke integrations.
Okay, let's dive in then. What exactly is this MCP everyone's whispering about, and why the sudden buzz?
Well, picture this. Before MCP, if an AI wanted to chat with, say, your calendar app or pull data from a database, it was often a um, very bespoke process. Think of it like needing a specific handcrafted cable for every single connection. Manual API wiring, special plugins, sometimes even entire agent frameworks had to be built just for that one task.
Right.
Each connection was basically a unique project, which, like you said, isn't exactly efficient. It's like trying to get your old flip phone to connect to your smart TV.
Yeah,
They just don't speak the same language.
right. Sounds like a developer's nightmare, honestly.
Yeah.
So how does MCP play the role of digital diplomat here?
So MCP steps in with a standardized protocol.
Hmm.
Think of it as setting up a common language and a set of rules that all these AI applications and tools can agree on. Instead of building a unique connector for every single tool, developers can just build to this MCP standard. And the beauty of this is, well, the flexibility and scalability you get. Once an AI speaks MCP, it can potentially interact with any other tool that also speaks MCP.
Okay, and here's where it gets really interesting, I think. I'm seeing that some of the big kahunas in the AI world are already jumping on the MCP train. Who are we talking about?
Exactly. And that early enthusiasm from the major players, that's a really strong vote of confidence for MCP's future. The key takeaway is that stamp of approval from industry leaders, right? It signals its potential as a future standard. Giants like Anthropic and OpenAI are already using MCP to make their AI agents much more versatile. It lets these agents handle more complex, multi-stage tasks that need them to juggle different tools. Imagine an AI that doesn't just answer your question, but then seamlessly schedules a meeting, sends a follow-up email, updates your project board,
Wow.
all through these standardized MCP interactions.
That's a significant power up for AI capabilities.
Right.
And it's not just the big players stateside, is it? I saw something about tech titans in China getting involved too.
You're spot on. Baidu, for example, has also integrated MCP into its AI ecosystem. This kind of global interest really highlights the potential for MCP to become a truly worldwide standard for how AI workflows are built, much like, how TCP/IP became the bedrock of the internet.
So it's not just for the AI heavyweights then. What about the folks in the trenches actually building the applications day to day?
That's a great question. And no, it's not just some fancy tech reserved for the AI elite. Developer platforms like Replit are also actively integrating MCP. And this is crucial because it shows MCP is moving beyond just an abstract concept and becoming a practical tool for everyday developers building AI-powered apps. It essentially lowers the barrier to entry for creating more sophisticated, interconnected AI tools.
Okay, so we're getting a good picture of what MCP is and why it's generating this buzz. But, with any new tech that connects different systems, you can bet your bottom dollar that security is going to be a major concern. To really understand the potential weak spots, we probably need to peek under the hood and see how an MCP server actually operates, right? What's its life cycle look like?
Absolutely. Understanding that journey of an MCP server, how it's created, how it's installed, how it runs, it's fundamental to spotting potential security vulnerabilities. Each phase, each stage of this life cycle presents its own unique set of challenges that really demand careful attention to keep things secure and running smoothly. It's a bit like studying the different stages of a plant's growth, to understand where it might be susceptible to disease or pests.
Okay, so let's shine a light on those potential security risks, starting right at the beginning with the setup of an MCP server. What are some of the first things we should be worried about?
Well, one of the early risks is something called name collision.
Hmm.
Imagine you're trying to connect your AI to a legitimate MCP GitHub server to interact with your code repo. Makes sense. Now, picture a sneaky attacker setting up a fake server
Mm-hmm.
with a very similar name, maybe FeastyB GitHub or, some other subtle variation that's easy to miss.
Ah, okay.
Your AI, just trusting the name and maybe a brief description it sees, could be tricked into connecting to this imposter server. And that could then let the attacker intercept sensitive info or even mess with your development workflows. Now, right now, this is maybe more of a concern in local testing environments, but it could become a much bigger headache in multi-tenant setups where you have lots of servers running together. The critical thing is that inherent trust placed in server names, it creates a prime phishing opportunity for bad actors.
That's like a digital wolf in sheep's clothing. It kind of reminds me of those fake Wi-Fi hotspots you see in cafes, you know?
Exactly.
You connect without thinking, and suddenly your data is taking a detour through who knows where. Okay, what's the next setup hazard?
The next potential pitfall is installer spoofing.
Hmm.
So to make setting up MCP servers easier, these unofficial auto-installers are starting to pop up. Things like MCP installer that even promise installation through simple natural language commands.
Oh, wow.
Now, while the convenience is tempting, I mean, who wouldn't want to just tell their computer to install something?
Yeah.
These can be quite risky. These installers often come from, let's say, unverified corners of the internet, community forums, maybe GitHub repos you haven't checked out.
So it's the digital equivalent of accepting candy from a stranger. Is that what we're saying?
Precisely. Attackers could easily embed malicious software within these seemingly helpful installers. This malware could then grant them unauthorized access, mess with your system configurations, or even create hidden backdoors for them to exploit later. And the really concerning part is that many users who go for these one-click solutions, they often don't bother to scrutinize the underlying code. It's like clicking agree on a software license without reading any of the fine print you might be signing away more than you realize.
Yeah.
This lack of thorough inspection just makes it much easier for malicious versions to spread around undetected.
That sounds like a recipe for digital indigestion. Are there any other dangers lurking during this initial server setup phase?
Yes, and this is a more general concern, but still important. Code injection, or the deliberate introduction of a backdoor during the server creation itself. Even if you're being careful not using an auto-installer, if the source code you're using to set up the server isn't from a highly trusted source or hasn't been properly vetted, well, malicious code could be intentionally or even unintentionally included. And this could give an attacker a secret way into your system right from the start.
Okay, so we've navigated the potential minefield of just setting up an MCP server. What about the broader security challenges that pop up as MCP gets adopted more widely? It sounds like we're in a bit of a tech frontier right now.
You've hit the nail on the head there. One of the major hurdles is definitely the lack of centralized security oversight. Because these MCP servers are often developed by all sorts of different people or teams, there isn't a single authority setting and enforcing consistent security standards. This decentralized approach can lead to a real mixed bag of security practices, making it really hard to ensure that all servers are built with robust security from the ground up. It's like having a neighborhood where everyone builds their houses to their own, personal standards. Some might be fortresses, others might be built on shaky foundations.
That makes perfect sense. Consistency seems like it would be a cornerstone of any decent security strategy. Are there other areas where this lack of standardization is causing potential headaches?
Absolutely. Another big gap is in authentication and authorization. Currently, MCP lacks a standard, built-in way to handle logins and permissions across all the different clients and servers. Without a unified system to verify who is who and what they're actually allowed to do, it becomes much harder to control access, especially in environments where you might have multiple users or multiple AI agents interacting with the same server.
Right.
This lack of strong authentication just ramps up the risk of unauthorized tool use and potential data breaches. Plus, different MCP clients might handle user credentials in their own unique ways, maybe securely, maybe not, further complicating things.
So it's like trying to run a secure building with a different lock and key system on every single door.
That's a great analogy, yeah.
What happens when things inevitably go wrong? How easy is it to figure out what went sideways?
Well, that brings us straight to the challenge of insufficient debugging and monitoring. Right now, it's not always straightforward to track down errors or get a clear picture of what's actually happening when AI agents are using tools through MCP. Because the clients and servers often operate independently, issues with error reporting and logging can actually hide important security events or even just basic operational problems. Without good monitoring tools and standardized logging, it becomes much, much harder to spot anomalies, prevent failures, and effectively respond to security incidents when they occur. It's like trying to diagnose a problem in a complex machine when none of the warning lights are working properly.
And MCP enables these really complex multi-step workflows, right? Where an AI might chain together several different tools in sequence. Does that introduce its own set of security wrinkles?
It certainly does. Maintaining consistency in multi-step cross-system workflows presents another layer of complexity. Because MCP lets AI orchestrate the use of multiple tools, maybe residing on different systems entirely, ensuring the context and data flow correctly and securely between those steps. Well, it can be quite tricky. It's the distributed nature of it all. Without robust ways to manage the state of these workflows and recover gracefully from errors, there's a higher risk of things going wrong, data getting lost, or even being unintentionally exposed somewhere along the chain. Plus, coordinating across different platforms can introduce delays and conflicts, potentially undermining the whole process's reliability.
And as MCP scales up, starts handling more users simultaneously, maybe remote servers, I can imagine a whole new set of challenges emerging there.
You're absolutely right. Scalability challenges in multi-tenant environments are a significant concern as MCP evolves. Maintaining consistent performance, robust security, and ensuring proper data isolation for each user or tenant becomes significantly more intricate. Without strong mechanisms for resource management and tenant-specific policies, you run the risk of data leaks, performance bottlenecks where one user's heavy activity impacts others, and even privilege escalation across accounts.
Yeah.
Ensuring both scalability and robust isolation is going to be absolutely key for MCP to be a viable, trustworthy solution in enterprise settings.
And what about when we start thinking beyond just computers and software? What about integrating MCP into the physical world, like in smart homes or industrial systems?
Right, the challenge is in embedding MCP in smart environments that introduces a whole different set of considerations. These environments often have very specific demands, like needing rapid, real-time responses, needing to work with a huge variety of different devices, sensors, and of course, maintaining really strict security in that real-time context.
Yeah.
MCT servers in these scenarios would need to handle constant streams of data while also reacting almost instantaneously. Ensuring AI can interact seamlessly and securely with this diverse array of physical devices. Well, it presents some unique engineering and security hurdles that need very careful thought.
All these potential risks sound quite alarming in theory, but are these just hypothetical concerns, or are we seeing actual examples of these vulnerabilities being exploited out there?
Unfortunately, no, these aren't just abstract worries. Security researchers have already demonstrated that even sophisticated AI models like Claude and Llama 3.3-70B Instruct can be tricked into performing malicious actions through MCP.
Wow. Okay, could you paint us a picture? What do these attacks actually look like in practice?
Sure. One type of attack they've identified is called MCE, which is short for malicious code execution. This essentially involves manipulating the AI into executing harmful commands on the underlying system where the MCP server is running. In one documented case with Claude, when the malicious command was cleverly disguised using octal encoding, think of it like a secret code for numbers, Claude actually spotted the potential danger and refused the request. Which sounds good, right?
Yeah, like the safety rails worked.
Right. And here's the kicker in a slightly different attack, where the exact same harmful command was simply written out in plain English. Claude, while noting some potential security risks, actually went ahead and executed.
No way.
Yeah, and this resulted in creating a backdoor on the user's system, a secret entry point that could be exploited later.
That's both fascinating and deeply unsettling. So even with built-in safety measures, the models can still be vulnerable depending on how the instructions are phrased. What other types of attacks have researchers found?
Another really concerning attack vector is called RAID, which stands for Remote Access and Data Exfiltration. And this can even involve multiple MCP servers working together to achieve a malicious goal. Researchers showed how Claude could be manipulated into exporting a user's sensitive credentials, things like their OpenAI and Hugging Face API keys,
Oh.
exporting them straight to a Slack channel using readily available MCP servers. In some variations, the AI could even be tricked into performing what's called a remote access control attack, basically giving attackers unauthorized access to the victim's whole system.
Yikes.
These real-world examples really hammer home the point that while AI models have safety protocols, they aren't always foolproof when they're interacting through a seemingly legitimate protocol like MCP.
It sounds like attackers are cleverly exploiting the implicit trust we might place in these AI models, especially when they're communicating through what looks like a standard safe protocol. Are there any common patterns emerging in these vulnerabilities being found?
Yes, definitely. A recurring issue that security researchers are highlighting in MCP servers is command injection. This happens when a server takes input maybe from an AI, maybe from a user, and then uses that input to run commands on the operating system without properly checking or sanitizing that input first. So attackers can craft special input that includes their own malicious shell commands, effectively allowing them to execute arbitrary code on the server. It's like leaving an unlocked back door that anyone can just walk through and start messing around.
And what's been the response from the developers actually building these MCP servers when these vulnerabilities are reported to them? That seems like a pretty critical piece of the puzzle.
Well, alarmingly, the responses have been quite varied and, frankly, often not very encouraging. A significant portion of developers, around 45% according to one report, apparently dismiss the reported security risks as either theoretical or even acceptable. One rather concerning analogy used was something like, if you give a monkey a gun, it's not the monkey's fault. Which is, well, it's a major red flag, right?
Yeah, that's not great.
Even worse, about 25% of the developers didn't even bother to respond to the security disclosures at all, just silence. Only a relatively small fraction, maybe around 30%, actually acknowledged the issues and went on to release fixes. This lack of consistent attention to security across the whole MCP ecosystem just makes the entire landscape much more vulnerable.
That's a pretty significant collective shrug from a lot of developers. It definitely highlights the need for more standardized security practices and, frankly, a greater sense of urgency within the community. It's not just about building the next cool AI tool, it's about building it responsibly and securely from the start.
Exactly, and it's crucial to remember something else here. MCP servers aren't exclusively used by these large language models. As one insightful source pointed out, virtually anyone could potentially interact with them directly. Now, while LLMs often provide a kind of plan before they act, giving a user a chance to review it.
Right, you see what it's thinking.
Yeah. But a malicious human attacker, they don't have to be transparent at all. They can just probe and attack directly. This significantly broadens the potential attack surface, a fact that maybe many developers aren't adequately addressing, perhaps focusing too narrowly on just the LLM interactions and overlooking risks from other connections.
So given all these potential pitfalls we've explored, the setup risks, the broader challenges, the real-world exploits, the sometimes patchy vendor responses, what are some of the key guiding principles? The best practices that developers and users should keep firmly in mind to secure MCP deployments.
Well, a fundamental principle has to be treat agents as unpredictable clients. Because we can't always know exactly what prompts an AI agent will receive, the MCP server needs to be designed defensively. It has to assume it might get unexpected or even deliberately malicious requests. You can't just assume all incoming traffic will be friendly.
That makes sense. Assume the unexpected in the digital realm. What else?
Another key concept is to treat MCP servers as client libraries for external tools, end quote. An MCP server is basically acting as an intermediary, right? It's connecting to other tools and services. So it needs to be built with the same robust security considerations as any application that connects to external APIs. That means following all the established best practices for API security diligently.
And what about the actual communication channels involved? There seem to be a few points where things connect.
Absolutely. Secure communication is critical on two fronts. First, secure communication between the agents and the MCP servers. We need to be really mindful of what data is being shared with AI models, especially third-party ones out in the cloud. We need strict controls to specify exactly which LLM providers can access which tools and actively prevent sensitive data from being unnecessarily exposed. Like we discussed earlier, maybe restricting a tool that handles sensitive personal info to only be usable by a local LLM, not a cloud one.
Okay, and the second critical communication link.
That's the secure communication between the MCP servers and the underlying tools they connect to. When developers build those interfaces, they absolutely must follow the existing security best practices for those specific APIs, using secure authentication, encrypting data in transit, managing API keys properly, all that good stuff.
In this kind of interconnected environment, figuring out who or what has access to what seems incredibly important too.
Definitely. We need to prioritize secure user and agent identity. Developing consistent, reliable ways to identify who or what is accessing resources within the MCP ecosystem is just essential. It protects users from rogue agents and protects platforms from attacks. And interestingly, the MCP specification itself actually includes a draft proposal for using Oath, a really common standard for secure authorization for exactly this purpose. So there's movement there.
Okay, and given those worrying examples of dodgy installers, how can users make sure they're getting legitimate and safe MCP components?
Right. Securing the MCP supply chain is absolutely critical. Users need to be extremely cautious when installing MCP-based extensions, because doing so often grants pretty significant code execution privileges. Fortunately, tools are starting to emerge like Glomma that offer report cards for MCP servers. They evaluate them based on security, licensing, code quality, and they regularly reevaluate them. So checking for servers with good, consistent scores before you connect is a really smart move.
Makes sense. Beyond the setup and communication, what about the ongoing interactions, how data is handled, getting permission?
Yeah, implementing robust consent and authorization flows is paramount. Applications using MCP must have clear, transparent ways to get explicit user permission before they expose any data or invoke any tools on the user's behalf. No surprises. Users need to understand what's happening and have control. And developers, they have a responsibility to provide clear documentation of the security implications of using their servers, empower users to make informed choices, and naturally, implementing appropriate access controls and data protections within the servers themselves is key. Restrict access based on least privilege.
Are there other sort of, well, standard security practices that are particularly relevant here? Seems like a lot applies.
Oh, absolutely. Many fundamental security best practices are highly relevant. Things like following secure coding practices in all integrations, staying informed about the latest vulnerabilities, patching systems promptly. That's just table stakes. Developers should also proactively consider privacy implications in feature designs right from the start. Build privacy in, don't bolt it on. Implementing mechanisms for tokenification and authorization checks is crucial. You need a way to cut off access if a token is compromised or permission changes. Using methods like role-based access control, RBAC, or access control lists, ACLs, to manage permissions finally is also highly recommended.
What about some of the more technical nuts and bolts safeguards?
On the technical side, using TLS for network transport. Encrypt everything in transit, essential. Sanitizing all input data to prevent things like command injection or cross-site scripting, absolutely vital. Implementing rate limiting and appropriate timeouts helps defend against denial of service attacks. Developers also need strategies to handle DOS scenarios gracefully and continuously monitor for unusual patterns in logs and traffic that might signal an attack. Plus, proper firewall rules and network segmentation can limit the blast radius if something does go wrong.
Any other key technical points?
Yeah, a few more. Avoid exposing internal error messages. Don't give attackers free information about your system, but do securely log all security-relevant events for later analysis if needed. Handle timeouts properly so processes don't hang, clean up resources after errors, rigorously validate return values from tools to make sure they're what you expect, and maybe most importantly, from the user's view. Always obtain explicit user consent before invoking tools or LLM sampling, and clearly document each tool's functionality and potential impacts so users aren't guessing. Implementing safeguards that restrict tool operations to pre-approved scenarios and ensuring the whole sampling process is transparent are also vital for trust and security.
Wow, okay. So, as we can see, this model context protocol definitely has the potential to really streamline how AI interacts with the world, making things more efficient, more capable. But it's also clearly a landscape dotted with some pretty significant security considerations. The rapid adoption we're seeing is exciting, no doubt, but it also means we all need to be extra vigilant, extra proactive about these potential vulnerabilities. It's a bit like getting that super handy universal remote for all your devices. It's amazing when it works flawlessly, but if it falls into the wrong hands or has some hidden flaws, well, things could get complicated very quickly. This deep dive, we hope, gives you a much clearer understanding of what MCP is all about and some of the key security aspects to keep top of mind as this technology continues to evolve and mature.
Indeed. It's a powerful and promising technology, absolutely, with the potential to unlock a whole new era of interconnected AI capabilities. But like any powerful tool, it demands really careful, really responsible handling. And a strong, unwavering focus on security right from the very beginning. The ongoing research, those early demonstrations of attacks, they serve as a clear reminder that we're still in the relatively early stages of both understanding and effectively securing this emerging landscape. It will be fascinating and absolutely crucial to watch how the community addresses these challenges as MCP continues to develop and gain wider adoption.
Absolutely. It's definitely a space we'll be keeping a close eye on. Thank you so much for sharing your expertise with us for this deep dive into the model context protocol.
My pleasure. It was great chatting about it.
Thank you for listening. Stay tuned.